In April 2021, the Chang'e, the core module for China's Tiangong space station, joined the International Space Station in low orbit. With the rest of its modules scheduled to join it in the coming years, China will now have its very own exclusive slice of space. That's the key word here, exclusive. Comparing the ISS and the Tiangong isn't just a tale of two space stations. It's a tale of two ideologies. On the surface, the two stations are actually quite similar. Their main difference is their size. Even if all of its planned modules are fully deployed, the Tiangong will only possess a fifth of the mass of the ISS. That's roughly 100 cubic tons to the ISS's 484. Despite this difference in size, the Tiangong will be more space efficient than the ISS. At its peak operational capacity, the Tiangong is slated to be able to house 12 astronauts. The most people ever recorded on board the ISS was 9. Most of the differences between the ISS and the Tiangong lie in the circumstances behind their respective programs. The Tiangong space program began in 1992 under the codename Project 921-2. This was to be China's third major space program, with its previous two attempts, Project 714 in 1971 and Project 921 in 1992, both failing due to various political reasons. Project 921-2 was conceived with one primary source of inspiration, the former USSR's Mir. Heavily inspired by all the groundbreaking scientific development and research taking place on the Mir, China realized that it needed to prioritize the deployment of a space station sooner rather than later. But progress with the country's space program was beset by all manner of setbacks. One of the most significant of these setbacks occurred in 1999. Talks calling for collaboration between NASA and the China National Space Administration, CNSA, broke down in 1999 as U.S. government officials saw this as a potential security risk. Being left largely to their own devices for decades, the CNSA was only able to send its first astronaut, Yang Liwei, into space by 2003. After almost 50 years since the program's inception, they were finally gaining the momentum they were looking for. During this stretch of time, another space station heavily inspired by the Mir was under construction, the International Space Station. Perhaps one of the most complex undertakings in human history, it required a constitution's worth of treaties and agreements to be drafted just to enable its construction and use. It was aeronautics' first supergroup. The ISS was constructed and operated by the United States NASA, Europe's ESA, Canada's CSA, Japan's JAXA, and Russia's Roscosmos, beginning its full operation in 2000, with talks underway about extending its service years well into 2028. The ISS hopes to make good on its initial promise of functioning as a permanent base of operations for space-based research. However, several of its systems are showing signs of age, particularly its solar panels. Over its 2 decades of service, its power draw has been gradually growing less and less efficient. This, among other limitations imposed by the ISS's aging technology, puts into question the feasibility of extending its service years to this extent. The introduction of the Tiangong, on the other hand, can benefit not only the aeronautics community, but humanity at large. It has rejuvenated the competitive aspect of the space race, and the basics of economics will tell you that competition breeds innovation. China's space program has things it feels it has to prove. Programs like the Tiangong started in part to demonstrate the nation's capability of supplanting the West as the dominant power in global trade and industry. This type of motivation can only result in further resources and effort being committed to ensuring that all of its technology is at the bleeding edge of what is feasible. So how does all of this innovation in space benefit the rest of us? The technological innovations required to operate large-scale projects like the ISS have already trickled down to us here on Earth. For instance, robotics technology initially designed to handle station maintenance and repair has made its way into the medical industry. Thanks to newer, extremely precise robot tech, previously inoperable tumors can now be removed. As it stands, being relatively late to launch the Tiangong has given China's space program some unique opportunities in terms of what technology it was able to incorporate into its design. One such iteration is seen in Tiangong's solution for drawing solar energy to power its systems. Instead of relying on traditional photovoltaic cells like the ISS, the Tiangong uses gallium arsenide photovoltaic cells to draw its power. Usage of gallium in electronics is only a recent phenomenon, and it is highly regarded for its efficiency and resilience to heat. Engineers hope that opting for this material will allow Tiangong solar cells to not only be more efficient than previous designs, but also remain effective for longer periods of time. With the space race back in full swing, perhaps the day we explore the stars will arrive one day sooner.